Morning students. Last time I discussed with you about Bohr's model of an atom and also discussed about the achievement as well as limitations of the model. I told you this model unable to explain the Proto-Heisenberg principle, de Broglie principles, etc. etc. So in order to explain the photoelectric effect, de Broglie principle, I have to discuss about the differences between matter and electromagnetic waves. Even in order to explain the hydrogen spectra, I need these points to be cleared. Electromagnetic wave. Electron is electric, magnetic is magnetic. The wave which is associated with electric and magnetic field both. All the waves are originated due to certain disturbance. It may be sound wave or light wave or matter wave. If there is no disturbance, no certain type of wave is generated. Electromagnetic waves are originated if I switch on the tube light or bulb, the rays which are coming out of the bulb are electromagnetic waves. Even indicator, if I switch on the fan, some invisible radiations are coming out. Switch on the press, heating press. In case of heater, both visible and invisible radiations are coming out and are of electromagnetic behavior. And matter waves are associated with mass and velocity. The microscopic particles possess wave character, and in that case we call them as matter waves. Hydrogen atom, electron, proton, gold atom, carbon dioxide molecule, 100 carbon dioxide molecule. These cannot be observed with the naked eye, and hence in the path which are placed by due to disturbance are called as matter waves. So matter waves are associated with mass and velocity, while electromagnetic waves are associated with velocity, no mass, like X-rays, UV rays, infrared rays. Matter waves may or may not have electric and magnetic. If they are charged, then they may have electric effect. Otherwise, no electric and magnetic field is there. In this case, electric and magnetic field both are present, and both are perpendicular to each other, and both are perpendicular to direction of propagation. That this is electric field, that is electric field, magnetic field, and direction of propagation is there. Both the electric and magnetic field are perpendicular to each other, and both are perpendicular to direction of propagation. Matter waves always require some medium. They cannot pass through vacuum. They even pass through vacuum. In 9th class, we gave the example that tube light fluorescent is the cathode ray. The electrons are moving from one terminal to another within a tube, and these electrons and protons or post-charged particles are matter waves, and the radiation which are coming out of the tube are electromagnetic waves. So the matter waves always have velocity less than that of light, that is 10 to 8 meter per second. But electromagnetic waves are associated with constant speed, that is 3.0 times 8 meter per second. Frequency and wavelength will change, but the velocity remains. They move along with the source. Wherever the electron, hydrogen atom, neon, etc. move, the path traced by them is the wave. But they leave the source. Tube is there, the radiations are coming back. Heat press is there, as the radiation will come back. They leave the source. In this case, the wavelength is equal to h upon and v. H is Planck's constant, and is the mass, v is the velocity of a microscopic particle. But in case of lambda is c upon mu. So electromagnetic wave theory was proposed by James Clerk. How they are originated? I already told. If I switch on the tube light, the radiation coming out of the tube, switch on the bulb. If there is the indicator in your house, the radiation coming out from the indicator. Switch on the heating press, switch on the fan, some radiations are coming out. That is a source of electromagnetic radiations. Field, they are associated with electric and magnetic field both, not either or, both. And both are perpendicular to each other and direction of propagation. They are emitted or absorbed continuously. And they are moving with a constant speed, that is 3.0 into 10 to the 8 meters. Limitation. This theory is unable to explain the black body radiations. It is assumed, and it is a fact, the black bodies are perfect absorber and emitter of radiations. Photoelectric effect. Variation of heat capacity as a function of temperature. Hydrogen line spectra, that will take next time. So what is spectra or spectrum? Spectra or spectrum is the arrangement of electromagnetic radiations in the order of increasing wavelength and decreasing frequency. Up to 10th class, we only learn about the visible spectrum with your infrared, microwave, radio. The highest wavelength is of radio wave that is utilized in TV transmission, mobile network, etc. Violet, ultraviolet, X-ray, gamma ray, cosmic ray. Shortest wavelength, highest frequency, and that is they have highest energy. And these parameters are used in the 10th class. Mu is equal to C upon lambda, and 1 upon lambda is mu bar, that is C into mu bar. Then black body radiation. When we heat the iron, it changes to red and then yellow, then white flame is also. According to Max Planck, all the black bodies are perfect emitters or absorption of radiations. But these, the energy emitted or absorbed by them is not continuously but discontinuously. Electromagnetic wave continuously, but in this case not continuous but discontinuously. That is in the form of bundle of packets, and this bundle of packets is also called as quantum, and plural is quantum. And in case of light radiation, we call this packet as photon also. The smallest packet of energy, the energy of photon is equal to h mu, and mu is equal to c upon, and h is Planck's constant. Its value is already told to you in Bohr's theory, 6.626 in 10 to the minus 34 joule second, joule per second, joule second. Generally 0.26 is not considered because they hardly disturb the net result. Since either 2 or 3 or 1000 or Avogadro number bundles are emitted or absorbed, when add this whole integer, means the total amount of energy emitted or absorbed is equal to this. There are some numericals, the total energy is provided to you. You have to find out how many photons are emitted. Means E upon H. H will give the value of N, the total number of photons. Now next topic is photo effect. This was not explained by the Bose as well as electromagnetic wave theory. The definition is the effect by which electrons are ejected from matter surface by the body radiation having frequency equal to or greater than threshold frequency. Threshold frequency is represented by nu naught. What is threshold frequency? The minimum value of frequency of incident radiation required such that electron just reach at the matter surface but not leave the surface. Here is the matter. The electrons are uniformly distributed in the matter to balance the positive charge. Nu is the frequency of incident radiation, nu is the frequency of emitted radiation. When the electron leave from matter surface, let us see. If the threshold frequency which is needed such that electron just reach at the matter surface but not leave the surface. So if the incident radiation is less than threshold frequency, then in that case the electron will not reach at the matter surface. The electron will not reach the matter surface. No disturbance is observed, hence no photoelectric. But if nu I is equal to nu naught, incident radiation has frequency equal to threshold frequency, then the electron will reach at the matter surface but not leave the surface. Means kinetic energy of ejected electron is 0. Means they just move at the surface but not leave the surface. But if nu I is greater than nu, the electron will leave the matter surface with frequency nu e or kinetic energy half mv square. So the kinetic energy of ejected electron is equal to the frequency difference. So half mv square equal to h into nu I minus nu naught. But because the energy is equal to h nu, the energy difference of incident radiation is h nu I and threshold energy is h nu naught. So h nu naught is also called as work function. So this formula is only applicable if the frequency of incident radiation is greater than threshold frequency. And nu is equal to C upon lambda, then another h C upon lambda I upon lambda naught. Nu I should be higher and lambda should be lower because frequency and wavelength are opposite to each other. So you can solve one or two numerical just for practice purposes. Learn all the theoretical concepts of this photoelectric effect. What is spectrum? Next time I will discuss about what is spectroscope, what is spectrometer, spectrograph, types of spectrum.